Hey students, today I'm going to be showing you how we can use our graphing calculators to model a bunch of points and come up with a function that models that data. It could be a linear function, could be a quadratic, a cubic, a quartic, exponential, logarithmic. And so I'm going to be running through an example, the example that's on the screen right now, going through this type of problem. So if you look on the screen, it says that a shot putter throws the shot, the metal ball, at several different angles to see what angle of release will give the optimal distance for the ball to travel. The angles listed below are measured in degrees above the horizontal, and the distances traveled are measured in feet. Full disclaimer, I made these numbers up. I have no idea how far a shot putter throws the shot, so apologies to all your track and field athletes out there. All right, so first thing we want to do, it says right here, use your calculator and come up with a quadratic function to model this data. So I have my calculator, the emulator, up on the screen right now. And where we are going to go to put in data that was given to us in a table, just as a series of points, is the stat button. It's in the same row as my green alpha button, the second row from the top, 2 over to the right. I'm going to click stat. And we have a couple menus here, but the menu we're on is where we want to start. It says edit. I do want to edit my data stored in my calculator, so I'm just going to go ahead, hit enter. Now, on the screen, you can see L1, L2, L3, L4, standing for list 1, list 2, list 3, list 4. There's nothing in my lists, and so I'm ready to just enter things. But let's say you had some data stored in your list already, something like this. How you can get rid of that is if you go up to the top of that list, L1, don't hit delete because that will delete your whole list. It's not catastrophic, but it takes a little bit more to get it back. Instead, just hit clear. So I'm going to hit the clear button over there in the top right. And then I'm going to hit enter, and it will clear all the data out of the list. So L1 is where we are going to put our independent variable, typically, our x values. And in this problem, the release angle is what dictates how far the shot travels. So I'm going to go ahead and type in each of those release angles. So 10, 20 degrees, 30 degrees, 40, all the way to 80. And then I'm going to scroll to the right one to get into L2, and L2 is where we're going to put our dependent variable. This is the distance traveled in feet. So 10 degrees, the shot went 40 feet, then 55 feet, 65, 77, another 77, 75, 71, and 64. Hitting enter after each of those. All right, so now I've put all my data in the list. And if we want to see what this data looks like, I'm going to hit the y equals button in the very top left, right there of my calculator. And I don't have any equations in my y equals, but if I hit the up arrow, I can turn on plot 1. Scatter plot 1 is what uses list 1 and list 2 by default. So up there, I'm going to hit the enter button. I'm going to go down. And if you ever need to adjust the settings for your plots, you can hit second and then the y equals button. You can see it says stat plot up there. And it can, if you hit enter for plot 1, you can change the color, you can change the type of dots, the lists it uses. But we're not going to need to do much of that because we put our data into that L1, L2. So in y equals, plot 1 is highlighted. If I hit graph, it should plot the points on a graph. But for many of you, I'm guessing you see the same thing I do, which is just a blank screen, just the coordinate plane. The reason is, don't forget, you might need to adjust your window. My window right now is set to -10 to +10 in the x direction, -10 to +10 in the y direction. But my points don't lie in that frame. So I'm going to change this. I'm going to say in the x direction, maybe go from 0 to 100. I like kind of nice round numbers. And X scale is how often I put a tick mark. I'm going to make that 10. And then the Y's, I'll go ahead and just make it 0 to 100 as well, counting by tens. We'll see the first quadrant. And if I hit graph now, I can see all those points coming from my lists in the stat section of my calculator. So I've got these points in here, and I'm asked to come up with a quadratic function to model this data. We can see it kind of looks like a downward facing parabola, but we can do better than kinda. The calculator is going to help us. If you hit stat again, and instead of editing the data in our lists this time, what we're going to do is we're going to scroll right to the calc menu. And we can do a lot of things in this menu. You can see we've got 1 var stats, 2 var stats. We've got linear regression. That's what linreg stands for. We've got quad reg, which is quadratic regression. Cubic reg, quartic reg, logarithmic reg down there on number 9. We've got lots of these different regression options. And this is how we're going to ask the calculator to come up with an equation that models this data. So I'm going to go to quad reg because I was asked to come up with a quadratic function. And one of two things will happen when I hit enter. First, if you are on the same operating system that I am on, you will see this menu. If not, you will just see quad reg on your main screen. I'll talk about that here in just a second. But quad reg in this menu, it says the X list is L1. That's where we put our X's. The Y list is L2. That's where we put our Y's. Don't worry about frequency list, but I would recommend in store regression equation that you put Y1. We want to store whatever equation the calculator comes up with into Y1. So how I'm going to do that on this newer operating system is I'm going to use the shortcut to get to my Y's. I'm going to press alpha, trace, and right here, you can actually see I can just select Y1, Y2, wherever I want to store this equation. And I'll hit enter for Y1 because that's a great spot. Now, if when you pressed quad reg, quadratic regression, you did not get this menu, you just got the screen that says quad reg, waiting for you to press enter, your main screen, then what you want to do is go to vars. It's a little bit under that left arrow. Right under that left arrow, it says vars. You're going to scroll to y vars, y variables. You're going to hit enter when we're on function, and you can pick Y1 that way. And so your screen, if you're on that other operating system, it'll just say quad reg Y1. And that's how we store the equation in Y1 on those calculators. But I'm going to go ahead and click calculate, which calculate thinks for a second, and then it gives me this readout. It says quadratic regression, y equals ax squared plus bx plus c. And it gives us actual values for a, b, and c. A, negative 0.02. B, 2.1309-ish. C, 20.6071. And then this r squared value. Now, the r squared value doesn't appear in that equation at the top. It's a measure of how well this model, this curve, fit our data. A perfect match would be 1.0. And so 0.986, is like a pretty good match. As we will see here in a second, the calculator feels confident this curve fits our data well. But what it's saying is it gives us A, B, and C values. It's saying a great equation to fit your data would be negative 0.02x squared, since that was A, plus B x's, so 2.1309 x's, plus C, 20.6071. And the nice thing is, if you click y equals now, that equation with all of its decimals, not rounded at all, is stored in Y1 for us. We didn't have to type it out or anything. So now here's the cool part, hit graph. And we can see that, yeah, this parabola, this curve fits that data pretty well. It's not a perfect match. It doesn't hit every point exactly, but it does do a good job of modeling the data, and we can use that equation to predict other values. So let's get back to OneNote and see some of these questions I'm asked. what is the equation your calculator generated? So question number 1 right here. I'm going to hit y equals, actually, second quit. I could have pulled it from the readout from the quadratic regression, but it's gone. So I'm going to hit y equals, and I'm going to say y equals negative 0.02. I'm going to say x squared plus 2.1309 x's. I'm going to keep 4 decimals and just truncate it at that 4th decimal. And then I will scroll over a little bit. Again, this is where I probably should have written it down when I first received the equation back. So scrolling to the x, that's how many x's, plus 20.6071. So plus 20.6071. That's the equation that our calculator came up with for us. So then the next question on the screen, it says, according to the model, what is the optimal release angle? What release angle would give us the best bet of throwing the shot the furthest according to our model? I'm going to come back to graph. And the x-axis represents the release angles. The y-axis represents how far that shot traveled. So really what this second question is asking is, how can I get it the furthest? How am I going to hit that maximum on the parabola? So here's what I'm going to do. I'm going to press second calc, and I'm hoping you remember this from other calculator tips and tricks. But that calculate menu lets us on the graph calculate a number of points, value, 0, minimum. What we are most interested today is maximum. So I'm going to come down to 4 and hit enter. And the calculator will ask me 3 questions. It will say left bound first. It'll say, give me a left boundary, trying to narrow down that search area. So I can either scroll with my left arrow to the left on the graph of where the max is. It goes kind of slowly though, oftentimes. So I'm actually just going to type in a value. I'm going to say 30. Because 30 definitely looks to the left of that maximum. And I should also point out in the top left of your calculator screen, it shows you what function you are calculating the maximum of. For us, it's y1, because that's all we have in there. But if you have multiple curves on the screen, you might need to adjust that. All right, we gave it a left bound, right bound, I'm going to say 70. It doesn't have to be super specific. It's just narrowing down, and you can see the lines of my graph saying, is it between here and here? Answer is yes. It asks us to guess. I'm going to guess like 50 because that's kind of what it looks like. And it calculates and it tells us that the maximum of this function is when x equals 53.2738, y equals 77.3691. So what is the optimal release angle? Remember, that's the degrees. So 53.2738. I'm going to go ahead and put that down, 53.2738 degrees. That, according to our model, is how we are going to, succeed in our shot put event, throw the shot the furthest. And the next question says, at this angle, how far would we expect the shot to travel? Well, that's just the y-coordinate, right, of the maximum, because that's what was graphed on the y-axis, 76.3691 feet. Is what we're expecting the shot to travel if we release at that 53-degree angle. So using the data points we were given, we used our calculator to come up with an equation, which we can now use to predict other values. What would the optimal angle be? How far would it go? 77.369. That's how we can get a little extra distance out of our throw. The same shot putter released the shot at an angle of 27 degrees. According to our model, how far will the shot travel? Well, I'm going to show you 2 ways to really find this pretty easily. The first way is going to be, if I am on this graph, I can press the trace button and type in any value I want, 15, for example. Oops, let me go back. Graph, trace. What I forgot to do, if you look in that top left again, it says plot 1, list 1, list 2. I don't want to trace my plot. Those are just the data points. I want to hit the down arrow and trace y1, that function in y1. So I'm going to hit trace. go down to y1, and I can type in 15, and notice on the screen it says x equals 15. Well, if I hit enter, it will jump on that curve right where x is 15 and say, if I release that shot at a 15-degree angle, I'd expect it to go 48 feet or so. I could say, what about an 81-degree angle? Almost like really steep, almost straight up. I'd expect it to go only 61.99 feet. What we are interested in, of course, is 27 degrees. And we're using our function that we came up with to estimate this. We are guessing that our shot would go 63.5628. 63.5628 feet. So the trace function is really useful when we know the x value, we want to find the y value. We can hit trace, we can type in the x value, it will find us the y value. Now, I did mention a second way that we could do this. Once we have our function in y1, we can use sort of function notation to evaluate. I'm going to hit that alpha trace. That's the shortcut to get to my y's. y1, and just like f of 27, f parenthesis 27, I'm going to say y1 of 27, kind of like how it looks on there on the screen. That's me instructing my calculator, please plug in 27 into that function that's stored in y1. I'm going to hit enter, and there's that 63.5628 again. So two ways, either tracing the graph or plugging it in to y1 using that function notation. Got one more question though, one more thing to show you with this problem. What if we knew the y, but we didn't know the x? The shot putter had a throw that traveled 72.1 feet. According to our model, what was the angle of release? Can we almost reverse engineer what angle the shot putter released that at? So our calculators are not great at this because we can trace and we can type in an x value, but it's not as good at receiving a y value and telling us where that x was. And it has to do with functions. If I said 77 feet, going back up to the table, would it tell me 40 degrees or would it tell me 50 degrees? I don't know. Both of those were 77 because multiple x's can go to the same y. But here's what I am going to do. If I know the y value, there's a really pretty simple way to figure out where my blue graph hits that y value. And here's what I'm going to do. I'm going to go back to y equals. I'm going to add a second function into y2, and I'm going to say 72.1. As it's graphing, recall that this is a constant function. It goes straight across the screen, and every point on that graph is a point where the y coordinate is 72.1. So now that I have that graphed, my job became a little easier because I can't just type in a y coordinate and ask the calculator for the x. But what I can do is if I go back to that second calc menu, second and then the trace button, if you look at number 5, I can calculate the intersection between two curves. So I'm going to press 5 to go to intersect, and it will give me 3 questions again, different questions. The first one says first curve, and I can use the up arrow and the down arrow to say which one is my first curve. The reason it's asking me this is, what if I had 5 different curves on this screen and I wanted to find the intersection of 2 specific ones? I need to specify which 2 to find the intersection between. So first curve is y1. That looks great. Blue is one of the things I want to find the intersection between. Second curve is the next question, and yep, red looks good, y2. Then it will ask me to guess. And as you can see on my calculator, there are 2 spots that red hits blue. It's trying to figure out which one should it tell me. So I'm going to say, you know what, I think it's around 40. My guess is x equals 40. And that lets it know to do the one on the left that's closest to 40. It says the intersection x equals 37.0424 if we truncate. So 37.0424 degrees is one way, according to our model, that we could land our shot exactly 72.1 feet. But there's a second place too. So I'm going to say or, and I'm going to repeat that process, but give it a different guess, give my calculator a different guess. So I'm going to say second calc intersect. So I'm going to press 5. First curve blue, sounds great. Second curve red, sounds great. Guess, this time I'm gonna say like, I don't know, 70-ish, it's way over there. And I was actually pretty close, 69.5051. 69.5051 degrees. And this is how, if we know the y coordinate, we can fairly quickly find the x coordinate to go along with it. Where did the shot travel 72.1 feet? Well, it happened when our shot putter released at an angle of 37 degrees or 69.5 degrees. That's what we're projecting anyway, according to our model. So this is what I wanted to walk through with you on this video, just how to use the calculator to A, put in a bunch of points, B, have it plot those points for us, C, ask it to come up with a function, come up with an actual equation that models the data so that we can make guesses and predictions about other values. Those guesses and predictions in this case were, what is the optimal release angle? Find the maximum of that parabola. How far would we expect it to travel? Again, state the actual maximum, whereas the optimal release angle is where the maximum occurs, the x coordinate. If we release the shot at an angle of 27 degrees, how far would we expect it to travel? So trace 27. And then if we know that the shot traveled 72.1 feet, kind of figuring out, going backwards, what angle was that shot probably released at, and using this idea of a second function that can intersect with our first function. So hopefully this was helpful. Hopefully it's a nice walkthrough. If you have any questions, please definitely let me know. Feel free to ask me. Otherwise, I will see you next time.